So good afternoon everybody, myself Acharya Vishvendra, and let's discuss today a worksheet on angular SHM. So let's begin with the worksheet. So here is a simple pendulum having amplitude 4 degree, and here is a rigid wall, and all the collisions are given to be elastic. So the first question is we need to find time taken from A to B. So you can say that if pendulum is released from rest at A, it is the extreme position and B is the mean position. So from extreme to mean, the time taken is T by 4. So which is 1 by 4, and T is equal to 2 pi root L by G. So it simplifies to pi by 2 root L by G. Then we have time from B to C. So if 4 is A, then 2 is A by 2. So as per calculations are concerned, we need to find time taken to move from 0 to A by 2. And we know that it is T by 12. So using calculations, we get this. Then again from C to B, same time will be there. From B to A, T by 4. If we calculate the total time after final calculations, it comes out to be 4 pi by 3 root L by G. Next is we need to find speed of bob at B. So here theta is theta naught cos omega t. So at point B cos omega t is 0, that means magnitude of sin omega t will be 1. So after calculation, speed comes out to be L theta naught into omega. Now speed at C, using the same concept, we take theta is 2 degree, theta naught is 4 degree, so cos omega t comes out to be half. So sin omega t will be root 3 by 2, so speed will be V L naught omega root 3 by 2. Next is impulse on bob at C. The impulse is change in momentum. So as we can see that it will strike like this, and since collision is elastic, so it will retaliate by 180 degree. So the change in momentum is 2 mv. So substituting the value of V, we get this as the impulse. Now is the next question, change in momentum. Change in momentum is equal to impulse, so same answer will be there. Next is we have 2 points S1 and S2, and a simple pendulum has a length of 3L, and we need to calculate the various times. The first is A to B. So we can see that initially simple pendulum will oscillate about S1, and the time is from extreme to the mean position, which is T1 by 4. Here in T1 length will be 3L, so this will be the time taken. Next, when it moves from P to C, it will oscillate about S2. So length will reduce to 2L, as L is over here, so the free length will be only 2L. So it will be pi by 2 root 12 by G. Next, same time will be taken from C to B, then same time from B to, and if we add all the times, it comes out to be T1 plus T2 by 2, and after final calculations, it comes out to be this much. Next is we are being given a rod. It is pivoted about a certain point P, which is at a distance of x from the center of mass. Then we need to find moment of inertia about P. So using parallel axis theorem, we can say that IP is equal to IC plus mx square. And we know that about the center of mass, moment of inertia is ml square by 12. Then is the time period. We know that T is 2 pi root I by mgx. So after calculations, it's come out to be this. Then we need to find minimum time. So we know that minimum time is 2 pi root 2k by g, where k is the radius of gyration, which is L by root 12 over here. So the minimum time will be this. Next is maximum time. It tends to infinity when L tends to 0. Next is Tx graph. So graph is like this, and it is minimum at a certain point where x is equals to L, k, the radius of gyration. Next is equivalent length of simple pendulum. So if we assume a simple pendulum has length 2 pi root L equivalent by g. So comparing the L equivalent terms, we have L equivalent is L square by 12 plus x square by x. Next is time period is found to be same for two different values of x, x1 and x2. So using the quadratic equation that t is equal to 2 pi root of this and solving for x, we get sum of roots as t square g by 4 pi square.